Thank you very much. I'm sorry for pressing you at the end of the day, but we may have time for one question before dinner, if there is a question or comment. Yes, well, we have two, one by Jim Peebles and one by Philip.
Well, my question really is to anyone who might know the answer. Does the universe have a non-zero angular momentum?
We recall that Hermann Weyl found a solution to Einstein's field equation in which matter is rotating everywhere. It would have the consequence, and it might be an approximation to the rotating primeval atom, but this solution had the consequence that there is a preferred direction of rotation. So Gödel looked into this. He decided that surely in his solution, the axis of rotation of the spiral galaxies would line up. And it is reported that after his death, it was found on his desk a set of photographs of nearby galaxies in which he had drawn lines along the planes in order to check whether there was some correlation of orientations. As it happens, we have been doing for years studies of statistical correlations of orientations. By and large, galaxies are remarkably randomly oriented, with the exception of a slight preference if you're near a mass of galaxies to be aligned with the mass of the cluster. But it doesn't look as though angular momentum is a global quantity. It is instead, I think, the interaction of neighboring galaxies, each with each other.
But, if you consider these graphics, you see that angular momentum of universe is very natural to expect, because it is the point, I don't show, the point of intersection of two lines, the Kerr line, angular momentum for Kerr black hole. It intersect in 2 points. In 2 points, intersect the lines of stars and planets, and lines for galaxies, clusters of galaxies, and maybe universe. And these points has very remarkable expression. The Chandrasekhar formula appears, and the Eddington formula for masses. If you reinstall the masses into formula for angular momentum, we obtain new formulas, which is looks very very interestingly from the point of large numbers of which Dirac and Eddington considered. It is not proof, but Birch tried to show directly that universe is rotating. Because after his work was criticized by some researchers, after they rejected this criticism, and I think the work of Birch is most observational proof, good observational proof of the possible rotation of the universe. Birch.
True.
Very quick question, follow-up to Bill's question and Jim Peebles' answer. There are very precise atomic clock experiments that look for asymmetries having to do with some preferred axis. Those are about to leap forward another 5 orders of magnitude. And so is there a possibility that that could see some put a better limit on rotation?
It would be marvelous, and 5 orders of magnitude could make an enormous difference. But I'll remind you that in a rotating universe, the redshift is different in different directions depending on whether the rotation is toward or away from you. In lowest approximation, a bit of rotation would produce a dipole, a quadrupole anisotropy in the microwave background temperature. The anisotropy is there. It's about what you'd expect from noise, and it's at a part in 10 to the 5th. So if the rotation is present, it is very tiny. Still, well, and we recall the Hughes-Drever experiment showing that locally space is very nearly isotropic.
And
In a decade, I mean, I just heard a talk from Jung Yi where I think the prospects of him getting on a non-zero angular momentum states, 10 to the minus 24 relative precision, 10 to the minus 22 likely. So, as opposed to microwave clocks that are 10 minus 15.
But there is other independent experimental observational proofs that the universe is not three-dimensional. It has some preferred directions. The statistical work, poor statistical work, was done by Lobo. He showed that the galaxies show this asymmetry. That there is preferred axis.
Okay, I think we'll stop there the discussion. It's an important question whether there is a global rotation or not of the universe, or maybe can continue during dinner time. Thank you very much again. And the session is closed now.